Hi and welcome to this Name the Time Signature quiz. So you can see what I have on the board are 3 different rhythms, and the idea is to see whether you can name the time signature. Now, it may be that there's more than one possibility in some cases. In other cases, it may be that there appears to be more than one possibility, but in fact there isn't. So you might want to have a little pause and see if you can work these out, and then come back to me and see if what you've come up with agrees with what I think the answer should be. So let's have a look at the first one up here. Now, when you're working these things out, it's not a bad idea, is it, just to work out what the basic unit of calculation might be. Now, you've got a couple of crotchets, you've got 4 quavers, so basically you're either going to count up the number of crotchets or count up the number of quavers and work it out from there. Now you might think, well, there's more quavers than crotchets. Well, okay, fair enough. Let's start on that basis. How many quavers are there altogether? 1, 2, 3, 4, 5, 6, 7, 8. So it means that you could take the view that this is in 8/8. Actually, 8/8 is not a time signature we use terribly often. But it doesn't matter as a starting point for calculation, because if you've got 8/8, well, you could think, well, what would happen if I double or halve the numbers? Well, if I double up 16/16, mathematically is possible, isn't it? Because if there are 8 quavers in that bar, there must be 16 semiquavers, but 16/16 sounds a bit unlikely. What happens if I halve it? I get 4/4. Now, does 4/4 seem a more reasonable proposition? Because it certainly does to me. The idea that we might have 4 crotchet beats in a bar. And that's where you might have started your calculation. You might have started by counting crotchets. There's crotchet 1, these 2 quavers make crotchet 2, these 2 make crotchet 3, and obviously there's a crotchet for crotchet 4. So 4/4 is an obvious answer. The other thing is, you might be looking at these quavers thinking, well, why not beam those quavers together? And beaming of notes is often an issue that causes a lot of grief. But when we're in 4 time, we try to show the middle of the bar. Okay, now there are exceptions to that, the most notable being when you have a rhythm that does this, a crotchet followed by a minim followed by a crotchet, where we can cross over the middle of the bar. But in other cases, we're trying to show the middle of the bar. That's why I didn't beam those together. So that's another little bit of a clue. So if you've got 4/4, well, you're absolutely correct. It's also true, though, that this could be 2/2. So you see how I'm getting there just by arriving at a mathematical possibility. Having got the mathematical possibility, you can double both the numbers, you can halve both the numbers, you can do that as many times as is reasonable. Then you can decide what the most obvious thing is. 8/8, when do you ever come across music in 8/8? It's pretty rare, isn't it? 16/16, even less likely. 4/4, incredibly likely because it's common time. But it's also true that it could be in 2/2 because we can also see 1 minim beat, 1 minim beat there. So either 4/4 or 2/2 would be correct answers to that first one. And as to whether in reality it was 4/4 or 2/2 might depend on things like the speed. So if it kind of really wanted a sort of presto speed and it was really dancing 2 in a bar, 2/2 would probably be better. If it was a march, well, 4/4 would probably suit the character more, wouldn't it? So sometimes speed affects that choice, but either of those are definitely possible. Now, what about the second one? What did you come up with for this? Well, probably the easiest thing to do here is to count quavers, isn't it? And see if you can work out how many quavers there are. When you see rhythms like this, they often cause a bit of confusion because you think, oh, I've got a dotted quaver and a semiquaver, what's that? One thing to bear in mind is that when you have a dot followed by an extra line, those 2 things sort of, if you like, cancel each other out. So if I got rid of the dot and got rid of the line, I would have 2 quavers here, wouldn't I? So in fact, all I've done is put a dot on there, which is compensated by that line. So it's a different rhythm than 2 quavers, obviously, but mathematically it's the equivalent of 2 quavers. Now, how do I test that out in maths? Well, this is worth 3/4. That's worth 1/4. So that gives me 1 in total. So if I cancel the dot, cancel that, it would give me 2 halves, which also gives me 1, doesn't it? So do you see, it's the equivalent of 2 quavers. So counting in quavers, 1, 2, 3, 4, and then 2 of these is giving me my 5th quaver, and this is my 6th quaver. So if it's 6 quavers, well, 6/8 is probably the answer, isn't it, if I'm counting in quavers. But before you let go of it, also just think, well, what happens if I double those numbers? 12/16, well, mathematically, absolutely possible. If there are 6 quavers, well, there could be 12 semiquavers, but a bit unlikely. Perfectly possible, because 12/16 is itself a compound quadruple time, but it doesn't sort of look like that, does it? I don't see 4 groups of notes, do I? I see 2 groups of notes, which is going to make it more likely to be 6/8. But of course, you could halve those numbers, couldn't you? And you say, well, if there are 6 quavers, there are also 3 crotchets. So it could be 3/4 maybe. Maybe some people got that as the answer. But does it look like a bar of 3/4? No, it doesn't look like 3/4 because I can't see 3 crotchet beats there. It doesn't look like 12/16 because I can't see 4 groups of 3 semiquavers. So it's the beaming of the notes that tells me that that is 6/8. The maths tells me that, but in order to eliminate 12/16 or 3/4, I've got to look at how the notes are beamed together. How they beam together? Well, here's one group of notes. Here's a second group of notes. Put those rhythms together, I get a dotted crotchet beat there, I get a dotted crotchet beat there, and that's how 6/8 works as a compound duple time. And it's why it couldn't possibly be 3/4, even though that's mathematically possible, and it couldn't possibly be 12/16. Also mathematically possible, but it doesn't beam together that way. So 6/8 is the only response you could have made to that. Okay, let's look at the next one. What do we think is going on here? Well, maybe the easiest thing to do here is count the crotchets. I've got 3 crotchets worth in this dotted minim, and then a pair of quavers and another pair of quavers. That's looking like 5 crotchets. 5 crotchets? What's this? So that would express itself as 5/4. Okay, let's double up. 10/8. Slightly unusual one, isn't it? 10/8. So I don't think it's going to be that. If I halve it, I'm going to get 2.5, 2. Well, that's not going to work because we don't get into fractions of numbers. So 5/4. Could that be 5/4? It certainly could. 5/4 is something we call an irregular time signature. And in a 5/4, you either have 3 plus 2 or you have 2 plus 3. 5/8 would just be the same. So I've got 3 plus 2. So that's really confirming that this one is 5/4, an irregular time signature. What about the next one? Oh my goodness me, lots of quavers here. So the thing that we're tempted to do is to count quavers. Perfectly reasonable. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Brilliant. So I bet a lot of people have come up with 12/8 because they see 12 quavers and they think, well, that must be it then. 12 quavers, 12/8. Mathematically, absolutely perfectly possible. Actually, the beaming says impossible. Why? 12/8 is a compound quadruple time. So in 12/8, this would look like this. You'd have groups of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that would throw up these beats. Because remember, in compound time, you organise things into groups of 3. So 12/8 would have to look like that. You'd have to have 4 dotted crotchet beats, which means the quavers would have to be into 4 groups of 3. So 12/8, mathematically possible, beaming says impossible. Okay, double the numbers, 24/16. Whoa, that sounds like a lot, doesn't it? I'm not sure that's going to be a good one. What happens if we halve the numbers? So that would give us 6/4. Ah, now maybe we're a bit nearer. We're in 6/4 because Yeah, I suppose that's if there are 12 quavers, there are 6 crotchets. So some people might have thought, yeah, great, 6/4 will do me very nicely. 6/4 is a compound duple time. So we'll be looking for 2 beats worth of stuff, wouldn't we? So if that's what 12/8 would look like, what would 6/4 want to look like? Well, 6/4 would want to look like this. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. Because in 6/4, I need 2 groups. So I need 2 groups of 3. So if there are 6 crotchets in the bar, I need 3 crotchets in one group, 3 crotchets in the other group, so that it gives me beats that look like this. I end up with 2 dotted minim beats. So still 12 quavers. There are 12 quavers here, but it looks different. The beaming for 6/4 is not the beaming we've got there. So we're a bit stuck, aren't we? 12/8 doesn't work, 24/16 doesn't work, 6/4 doesn't work. What do I do? Halve again. What happens if we halve again? Well, we get 3/2. So what does 3/2 mean? A simple triple time. So I've got to have 3 minim beats. Oh, let's look at how this goes. 4 gives me 1 minim beat. 4 gives me a second minim beat. 4 gives me a third minim beat. So this is the correct answer. Lots of possibilities. There are 4 possibilities for time signatures that we've considered. 24/16 we eliminated pretty quickly. 12/8 tempted us, but it doesn't look like 12/8. 6/4 tempted us, but it doesn't look like 6/4. And when we go to 3/2, we suddenly discover that the beaming of these notes dictates that that is the only option. So isn't it interesting with time signatures? Sometimes there is only one option. Sometimes you've got more than one option, but only one is authentic. Sometimes you've got 2 options, both of which are authentic. Sometimes you've got 4 options, but only one of them is authentic because of the way the notes are beamed together. Then we have things like this, where people kind of lose the will to live because they think, oh dear, I've got lots of extra lines, what on earth is all this about? Actually, this isn't too complicated really, because if you think of it in terms of semiquavers, there's 1 semiquaver here, these 2 demi-semiquavers are worth 1 semiquaver, and that's 1 semiquaver at the end. So really, this is going to be 3/16. You can't half the 3 because it gives you 1.5. If you double it, you get 6, and then what's double 16? 32. That's sounding a bit ridiculous, isn't it? So really, there's another example where 3/16 is your only option. So how did you get on with our Name the Time Signature quiz? And if that all goes smoothly for you, well, that's great. That should give you a bit of confidence. If you're sort of feeling a bit puzzled by all this stuff and why is it this and how does the beaming all affect things like this, very important thing to know about if you're a musician. Have a look at our theory packages, because all of this stuff is covered in detail, starting from the basics at grade 1 and building through the grades as we gradually explain all the detail of ever more complex time signatures, how the notes beam, and it helps you if you're writing music, composing, it helps you if you're playing it to understand what's going on. So an important area of musical knowledge really.